Well, good morning, everyone. At least good morning, everyone who's in London and that time zone. And welcome to today's FS Club webinar. Today's topic is the faux curtain of accuracy in systems that use artificial intelligence, or AI, or as I prefer, machine learning. But we have with us a real expert today, Kevin Maynard, who's the co-director of the Institute of Ethical AI at Oxford Brookes University. And you know me, I'm Michael Mainelli. I'm one of the directors of Yen. And it really is my privilege to be able to introduce many of these webinars. And I can only do so thanks to the generosity of our sponsors who allow us to range widely and freely across technology, economics, and finance. Kevin may hold himself forth as somebody who doesn't know a lot about finance, but actually, as we're aware, artificial intelligence and machine learning systems are rife in the financial services industry and rife across technology. If there's been a big theme for many of us over the last 20 years, it has been to go into any conference and hear big data, machine learning as being the one of the great themes of our time. But we are seeing these systems pop out into the real world, and they do pose ethical issues, which Kevin's going to explore with us today. Now, my job is to get out of the way and let you hear from our expert, which I'll do in just a moment. Kevin has reserved about 15, perhaps even 20 minutes for Q&A, and it's certainly a subject well worth discussing. So please do put your questions into the GoToWebinar question facility that you'll see on the screen. Please don't text them or email them to me because I'm here with you. I will get them later, but I'd like to feed them into the discussion with Kevin. The slides should be being posted just now so that you're able to refer to those if you need to or go back. And the recording will be going up in approximately 2 days' time. So with no further ado, Kevin, if I may, the floor is very much yours.
Okay, all right. So, just take it on to the next slide, Michael. Okay, thank you. I really appreciate the opportunity to come here. Just a little bit about the Institute is Institute main work is focusing on what I'd call more professional services rather than finance in, say, like use of AI in HR, law, social work, and things like that. So most of the talk is slanted around those types of things. But what is happening today is that we're starting to receive at the Institute a lot of people asking us to develop and evaluate some of the systems that they are buying. And what we're seeing is that there are a large number of these systems that seem to have serious problems. And what I'd just like to do is use some examples of why we think these problems are, and potentially what is the big issue that's actually building up in this world where we're applying these things or getting social scientists perhaps who don't understand how these things work, and they're going to crop up in 4, 5, maybe 10 years' time, where we end up with serious issues where we're not getting the results from the work that we want to apply in these fields. So next slide. So, whenever these people come to me, I ask them a very simple question. If AI systems are so great, then why aren't all the AI developers out of work? We're here for a reason. And what you're trying to do is buy in a system and just blindly block it out any help to do it and just use it without consideration. And so let me just show you some of the issues that we see coming up. So next slide, please. So the first one which I show people is this guy, Sean Battier, who's an American all-star basketball player. In other words, he's one of the best. He's the best of the best in that sense. But if you go and look at all the rankings, he's not there. He's not in the ranking for scoring. He's not up the top in rebounds, in assists. And you ask them, how does he become an all-star? Well, the simplest fact is that the reason why he's good is because the things he's good at are not measured, okay? And this happens in the social world all the time. What he does is block people from running. He gives the ball to somebody in a better position. And every team that has him in it does better on every other ranking, but it's not him. And this has occurred in an example that we've had come to us, for example, where social workers are now starting to use AI systems to identify kids who are at risk of being battered or hurt or harmed. And when we started to dig into the system, they started to realize that most of the data that social work, that the systems are built on, are the data that social work gathers in local councils. And the data that local councils get are the people who interact with them, people on benefits, people who come to try and sort out their bus pass and things like that. Most of those people, unfortunately, are people from lower incomes. There's little data for people from middle or higher incomes. And so therefore, when you go and look at these systems to look at-risk kids, you go, well, unfortunately, people from middle and higher incomes are just as likely to hurt their kids as people from lower incomes. And hence, what happens is these systems are not, avoid the word bias, they're just not accurate. They just do not deliver what you're trying to do. So if you use this system blindly, all you're going to do is just miss a whole huge number of people that you are responsible for. So that's the first example that is so common, is that they don't have the right thing. The second issue that I see is that people are misapplying the systems. And this, I used an example here, is facial recognition. Facial recognition systems are starting to become really, really good. Okay, they're excellent. And here are two examples to show how they can then be misapplied. So in the first case, we see border gates where you can go up there, they're totally automated. You put your passport into the machine, it takes a picture and compares it with your picture. If you're the right person, it lets you through. Gets high levels of accuracy. However, in the other case, the identifying people at football stadiums, South Wales Police started to use a facial recognition system to actually they set it up outside of Cardiff Arms Park and watch people coming out. And then they identified people they wanted to talk to. Maybe they had a car park, a motoring offence that would need to be picked up to, or something like that. And in the first case, the outcomes were really good. In the second case, the outcomes were really poor. Next slide. And the reason for this is that the system, which was really good, got put into a place where it couldn't ever perform very well. In the first case, what you're doing is a one-to-one match where you know exactly what the ground truth is. This is the person who I want, the border says is allowed to be let through. And they can take a picture and do a one-to-one match. It knows its ground truth. However, in the second system, what you've got is a crowd of perhaps, let's say, 60,000 people. And in their wanted database, the people they want to speak to, people with motoring offences and things like that, we estimated there was about 0.5% of people were in that category. And therefore, 95% of the people were not people they wanted to talk to. So if you do the calculations, that means there were 300 people in Cardiff Arms Park who were positive, and then that makes 59,700 people who were not the people they wanted to talk to. But this facial recognition system was 95% accurate. That meant that if you could actually do the take the picture of everybody coming out of Cardiff Arms Park, you would identify 285 people as positive, who were the correctly identified from people on that wanted list. However, because there's 5% inaccuracy in these machines, that means there would be 2,985 people who the machine thought were positive, who actually were not positive. That meant people who were then taken off wherever they were going to do. Maybe they were dealt with in the car park, or maybe they were taken off to the police station. That means 91% of the people were not correct. That overloaded the police, and there were a lot of unhappy public. The problem is that the ratios in these cases could never work. And to have a system that is 95% accurate, in my experience of building technology, that's a really high performing machine. To make this work such that it would be publicly acceptable, in other words, a low level of false positives, you would have to have something which is 99.9% accurate. And the only place that I've ever seen a machine that can be something like that is in a scientific lab where conditions can be controlled. In other words, this is almost an impossibility to get a machine that will actually do that, regardless of any claims. So the second one is the second reason that we see coming through that the context which the technology is used for is changed, and that changes the statistics to make it not work. Next slide, please. Okay.
So you wanted to have a bit of a poll here, Kevin, is that correct?
Okay. Yeah, okay, all right. So what we wanted to do was start to talk about in the social sector, we're trying to understand people's perceptions of using AI in the social sector. So we're interested in understanding whether you can identify places where there have been an AI system in the social sector that gave poor results from the outset.
Well, the poll's up and people are voting at the moment, Kevin. And, it is interesting. One, the whole false positive, false negative issue clearly applies in this time of COVID. So I think we're all getting familiar with that.
Okay.
But in addition, your examples do resonate where we've got things like identity systems in financial services. And equally, we have financial institutions rolling out supposedly services to help the financially non-included or to help people on lower incomes with savings. So a lot of good examples. Anyway, well over 3/4 of the audience has voted, so I'm going to close the poll. Oh, it's creeping up even further. Great, and I'll just show you the results, which is that 72% don't know if they've actually come across such systems, and then 19% said it gave poor outputs right from the start, and 10% they were working but then stopped or changed their performance.
Okay, all righty, thanks. So I'll include that in the next slide, thanks. Okay. So you just did a poll, and it's not surprising. Most people are unaware that these systems are being used. And if you or your family is going to come across, and even if you're coming from a wealthy family, you're surprised how many social systems come from the HMRC or healthcare or things which are got AI systems behind it, which in our estimate, a significant number of them have these contextual issues that we were talking about. And just to demonstrate that, this is a study that was done by an American university, not ours, but it really drives home that actually people are starting to implement things which are actually, the long-term impact is going to be quite serious. In this study, the university recognized that social workers were gathering loads of data from families over many years, and they took data from a particular state in America, 4,242 families they had gathered the data from, and they gathered 12,942 variables on each of those family members, and they gathered all that data, and they wanted to see if AI systems could actually accurately predict the outcomes for these people. What they did was give 495 data analysts the data from about 3,000 families and told them, go and use any model you like to actually try and model what the predicted outcomes of these people will be. Okay, so they went away, built these models, they brought those models back, and the university tested the accuracy of those families, the accuracy of the predictions on the social outcomes for those families on the remaining 1,242 families. Next slide, thanks. Okay, and these were the results. Okay, these are not our results. This is the university, the American universities. If perfect accuracy was a value of 1, and they measured social outcomes as material hardship, if the person was going to achieve material hardship in their 20s, their GPA, grit, and I don't really know the definition of grit, whether they're likely to be evicted from their house, whether they're likely to have get a sufficient job training, whether they're likely to be laid off at work. And of all the models that they had, and they had 495 models, the best model could predict was material hardship and achieved only a 23% accuracy. That's 23% accuracy for tools which are now being implemented in areas such as social work. And even worse than that, these organizations are taking on very expensive models, and the expensive models, which use neural networks and things like that, actually achieve no better accuracy on average than a 4-parameter regression model. In other words, there was very little value using the best technologies that people, the supposedly best technologies people could claim for these real world situations in social work. So next slide, please. So what's the summary of that? So there are some areas of AI where there's really genuine advance, say like medical diagnosis from X-ray scans, speech to text getting pretty good, facial recognition in some context. And usually this is where there's a real true ground truth. Okay, there's no doubt this is a positive result, and then you use the machine to actually achieve that. There are a second group of things which are not quite perfect, but improving, and sometimes they'll never achieve perfection. And I've made them to be things like spam identification, identifying plagiarism, hate speech. And partly the reason why they'll never be perfect is that it's almost like the virus. As soon as you counter take out a certain type of spam, it mutates and becomes a different type. And so there will always be a evolving environment. But there are huge numbers of areas where it is highly unlikely that you'll ever be able to achieve anything of serious accuracy. And they tend to be areas where you're trying to predict social outcomes, like job performance, at-risk kids, predictive policing. And the way I try and describe it to people is if you go out there and try and find a technology which reviews all the CVs of the whole world, I could still come up with Isaac Newton's CV, and you could actually still see that it was different from everybody else's. And that's because the world keeps evolving and moving in all sorts of various places. The input data is highly variable, the output decision making is highly variable, and even nobody can say what a true ground truth is. So, okay, next slide. So there are a huge number of world initiatives now trying to overcome this problem because they are starting to impact the real world. You know, the UK has the Centre for Data Ethics Innovation, a government body to try and bring people together to develop regulation in this sorts of areas in HR, etc. The EPSRC, the UK's Engineering Research Council, is investing £31 million to actually try and develop techniques to evaluate these things. And there are a large number of different other initiatives going on, and these are just a few globally, like AI Global's coming up with a certification process to actually be able to approve different AI systems. The European Union's coming up with a various number of rules and guidelines and ethics standards, and people like the World Economic Forum are starting to bring together different initiatives from around the world. And these are only some examples. Okay, next slide. So what do we do? Our focus is mainly on looking at the purchaser, because most of the money is being invested on developing AI evaluation systems for the AI developer. But the purchaser still is buying this thing and then applying it incorrectly. And so the first step we're doing is trying to divide up, if you're trying to develop an evaluation system, what's the responsibility of the AI developer and what's the responsibility of the AI user? Well, for us, the AI developer is responsible for, not surprising, the AI system, but also evaluating general risk for the applied use case. In other words, the developers can no longer hand it over to a user blindly. And the user, who usually will be a social scientist, actually not understanding any of that data, just uses it blindly. So the AI developer needs to take on some sort of responsibility for explaining the general use case. But that doesn't remove the obligation for the AI user, the AI purchaser, from doing some assessment for themselves. And the way I explained that is that if you get a social work system that works in London where distances are short, and therefore if there's an emergency and a decision has to be made, you've got a relatively short distance to actually make it. But if you take that system and then try and apply it, say in the UK's Highlands and Islands, where getting to somewhere takes a day often, if the weather is inclement, it's actually going to take you longer, then your decision-making process is going to change. And therefore, blindly applying the decisions of a machine in that context is not going to work. And therefore, you have to take some responsibility for developing an assessment system for your use case. Next slide, thanks. Okay. For those who want to go into details, this is how we break it out. These are only our suggestions, and they're being considered by various authorities. Next slide, thanks. Okay. And so just slowly moving towards the end here, is that this is the tools that we're developing for people who are buying these systems to be able to assess things for themselves. And that includes being able to do population analysis in more detail. There's nothing in rocket science about what we're doing. Being able to make assessments in compliance with laws, being able to develop proper functional modeling. So in other words, creating credible synthetic data or gathering better real world data, doing data quality assessments. Importantly, something which is really, I suppose, adding on for social sciences, to do a proper risk assessment. People in HR, people in social work have never really taken to heart doing risk assessments for their technology. They may do it for the risk assessment, say for an at-risk kid, but they now are taking on the need to take on the responsibility for the tools they use. And again, totally what wraps around all this is be able to do a proper contextual evaluation. The last slide, thanks, Michael. Next slide. As what they also have to do is take on the responsibility for doing continuous evaluation, because these systems frequently evolve. And not just the system, the social context, the law evolves. And therefore, whenever these people come to us, the final thing I tell them is that you need to think you're taking on the responsibility for actually doing a continuous evaluation cycle. And that is why the reason that you AI developers and AI creators are not out of work, because you're going to need them to actually help you develop and keep moving these things on as the data changes and as society changes. Okay, thank you very much.
Well, thank you very much, Kevin. That was super well within time, and that's a good thing too, because we've got a lot of comments out here and questions. While you grab a quick glass of water or something, I'm just going to read a somewhat lengthy comment, which I think will give you the tenor of the audience. This is from Ian in West London. He says there's a distinction between weak AI tools and weak deployment of AI. I.e., trying to deploy a good tool in an inappropriate place. Your examples of poor performance are clear in areas where policy or judgment comes into play. While AI can be excellent at eliminating heuristics and biases from logical or systematic problem domains, it can perform poorly or insert heuristics and biases into policy areas if poorly deployed. And he looks at parole, which he knows about. They eliminate the risk that the judge is grumpy just before lunch, but they're likely to look at people who come from inherently recidivist backgrounds and refuse them parole, which does nothing to address the root problems of recidivism. So, kind of grinding away at the same path. Anyway, I've got a few. I kind of thought so. So, Tanji Morgan has a question. She says facial recognition may be better, but it's well known that there are issues with people of color and certain ethnicities. This is due to the lack of diversity in the data sets that are used to create this. More concerning about facial analysis to determine creditworthiness, etc., you can see that there's a bit of a trade-off here. So do you consider these trade-offs acceptable? For example, you take a 5% false positive rate, or is it kind of no tolerance?
I fully accept the point that was being made there. The only issue that I was bringing up there was context is the key. So if 5% is tolerable, depends on the context, and you need data scientists to help the social scientists to understand the consequence.
Hugh Purser, I think it's because we've got the Six Nations starting tomorrow. He wants reassurance. Did the Welsh police force stop using the system after it delivered so many?
Absolutely. That's a real study. You can see it on the web.
Okay. Matthew Leach is.
Other police are considering it. It's not gone away. The issue has not gone away.
Matthew Leach, I think, makes an important point here. Would you propose a similarly rigorous evaluation for unaided judgment? So, in other words, the non-AI, the existing system,
that's a
only
really
rigorous.
Good question. Yeah. I think that's a really perhaps my analysis is that actually AI has the big advantages is that it's actually brought to the fore all these unvalidated judgments, whether they be human or machine. And just because you can analyze the machine, you're able to ask the questions. It's very hard to ask and analyze the judgment of a human. A very good observation.
Yeah. We've got a couple of questions related to this. So Donald McRae is saying, Kevin, are current AI models able to explain how a decision or diagnosis has been made, e.g. in medicine or law, so the conclusion can be seen to be made on valid grounds rather than on a spurious association?
Okay. And I can give a generalization.
Adds to that, it's sometimes said that AI developers can create systems so complex they cannot understand what the systems are capable of. Is this true or a myth? So two related questions there.
Okay, I have to answer this in the generalization because, again, it's very context specific. And you've got to be very careful about using the word explain. And it's now developed into explainability, interpretability, and challengeability. Okay, so explainability, at least in the way that we use the word, and other people use it differently, is actually joining the dots. In other words, what was the sequence of events that came to this decision? Okay, and sometimes you can do that, but it's totally meaningless. In other words, you could take a random forest decision tree and, say, went through this branch, this branch, this branch. Okay, but it doesn't really mean anything. Interpretability means that if I put these data coming in and these decisions coming out, can I understand why this data in created this data out, regardless of all the washing machine mixing that happens in the middle? Okay. And challengeability is that given the interpretability, have I got sufficient information to now challenge that decision adequately that would stand up in whatever appropriate court or, appeal authority that I have? And often it's the latter that people actually get wound up about. And I think maybe quite rightly so, because you can actually say, here's what happens, but can I actually do anything about it? So you say, you put this data in, or you are different from this person to that person, and that's why you didn't get the loan. But is that sufficient data to actually be able to enable you to challenge that decision? Because whenever you take it to someone, they'll go, oh, well, these other factors actually influenced it. So it is case specific, but you need to be careful with the language that you use these days.
Okay. Mark Duff, congratulations on a nice webinar. Mark is in the insurance industry. He says, in my industry, insurance, AI is being used as a tool to replace staff. These are repetitive tasks surrounding documentation review, creation, initiating the next process automatically. In your opinion, is this a better use of AI? And what do you think are the ethical issues surrounding that?
One could easily tuck out the issue about employment, because we work on quite a number of with a number of large companies to bring in new HR systems, and unfortunately, some companies are similar to I can't remember the chap's name. Are bringing it in to actually reduce staff levels, and that's a management and a board decision and a philosophy of the company. So there's an ethics of the company problem there versus it's not, just because you've got a tool that does it, the board can see what the consequences are, and they it's got nothing to do with actually the technology. You could reduce staff other ways. You could outsource and things like that. So it's the same sort of ethical dilemma in the broad sense. But is this tool then actually starts to make more inaccurate decisions? And what I've seen is that people have brought these systems in, starts to make decisions, and then somebody sat back and started to scratch their heads and say, this doesn't make sense. Then actually you see new group of people coming in who are perhaps more data savvy, what we call quantitative social scientists are coming in to actually interpret the data. So you could make an argument that whilst the overall numbers may reduce somewhat, what I see is there's going to be a shift in the type of person, people who can interpret the data better, who are going to be quantitative social scientists who can put things into context, and that profession will rise. It certainly won't be as many, but I've seen one company, a HR company, a very large tech company who wants to virtually reduce their total, everybody in their HR teams, which I disagree with in that sense, because I think they're just creating problems down the line.
This an interesting area in financial services has been the rise in the last few years of sandboxes, which are seen as quite popular amongst regulators. They're not without their criticisms. Chris Stonkwa wonders, though, do you have any advice for those running sandboxes like the FCA, particularly from the perspective of selecting potential participants and candidates to go into them? They're currently running their first digital sandbox, and some of the horrors you talk about seem to have got through, for example, a facial recognition solution. How should regulators be approaching this?
First of all, I thought you meaning sandboxes was a technical sandbox. And I was thinking, I'm not the tech. I'd have to bring someone from my technical team to actually give you the answer for the technical. But if you're talking about sandboxes where people are coming together to try and come up with ideas for solutions, my experience of those is one is they do come up with loads of great ideas, but I also see them extraordinarily exclusive. And the ones that I've been involved with, I think were totally unfair to the people who didn't actually end up in those boxes. Their views were totally ignored, and sometimes there were actually the right views to actually include in the sandbox, and you start to get a sense of self-importance. You've been selected for the sandbox, and so therefore your view is right. And with all these systems, the big thing, we ran a number of workshops to do risk classification, for example, and it sounds so silly. The key conclusion that came out of that was actually doing the workshops, because we had to have a limited number of people, didn't actually get to the right answer because we didn't have enough voices. So there needs to be other tools where you can get a bigger view of voices. And they're not simple, because you need to get people up to a certain level of understanding so they can actually make informed opinions into the thing. And you can't just pull somebody off the street without giving them some sort of training. So you've got this dilemma. You can't do a survey, because all you're going to get back is sort of almost don't know, or just random answers. But you have to have enough breadth in your training program to get people up to actually a speed where you get valid inputs. And so it is a dilemma. I'm not too keen on sandboxes in that sense.
I'm going to try and pull three comments together, which I think are quite insightful. Peter Hanley says there seems to be a large dependence on risk assessment before the AI product can be assured to be fit for purpose and safe. So will AI always be appropriate if we don't learn to use these risk techniques? And he goes on about, how do you set the expected accuracy you are looking for? That alone I can see as an ethical issue. Richard Parler wonders, should AI developers be required to disclose their algorithms? And I could see that certainly in regulated industries. And finally, Ian Sheridan says, is everything you're describing really just computational statistics, by which I mean, is the use of the word AI part of the problem? Interesting point.
I think all those are really insightful questions. I think they're good. The first one is, I think developing metrics is going to be, and from a research point of view, a really big part of the next generation in person, because, unless we start to get validated metrics, and that includes including all the voices of people, and how do you come up with one metric which is going to represent loads of different voices, it's a bigger challenge than people think, because in the past we used to have almost a black box where the government said we'll set the standard and everybody has to put it up with it. Now we have that box is opened up through the digital platforms. People are much more informed. People hear about things, and therefore government is struggling to be able to say I can set a standard, and then everybody else comes to meet that standard. So how metrics are developed for policy is going to be really important over the next 5 to 10 years. The algorithms, just remind me of the point with the algorithms.
So should developers be forced to disclose their algorithms?
I do go round in my head is that if there was things that you can actually understand better by disclosing the algorithm, perhaps it's valuable for things where you high risk things. So one of the things we're working with the CDEI on is developing a risk classification for different products and services. And that's to say, these are high risk applications, these are medium risk applications, these are low risk. For low risk applications, you go, well, what's the benefit of doing all that? And it just creates heartache, Whereas for high risk applications, say, for example, like autonomous cars or something like that, then there's a bigger case. But in those cases, you've got such complex algorithms, you could put the whole thing up on the board and anybody would scratch their heads to try and understand, because you've got loads of different input features. So, there's a principle that you should be able to get to it, but is there a practical delivery? And the third one is, I 100% agree. These are statistics. These are, the way I try and describe is using statistics is for people. When people do statistics, statisticians, they go and take their population and they try and look for outliers and they drop them. Well, for my social workers who come into me, they go and say, well, that outlier is not a statistic. That's the real world. The thing that's wrong is actually the statistic. This person is real. They're accurate. They know exactly who they are. It's the statistics that's wrong. So that is a very fair comment about these are, running things off the back of statistics brings its own problems, because they're not real. They're just developed, synthesized.
Well, I'm going to read a few more, if I may, comments and get to a question. Firstly, Trevor Hilder, I think tongue-in-cheek, has made a good comment. We'll just get the AI to do the risk assessment. And he kind of wonders, to what extent is the attraction of AI magical thinking? Richard Parler points out that an IBM survey showed that only 50% of AI projects actually contained any AI. So it's just being used to raise the costs of IT projects, or, in my opinion, high complexity. Peter Hanley's come back with, Kevin, you made a statement that the board can see the consequences of bringing in AI. Do we think boards actually have the capability of doing that? So let's look there. But turning to financial services, Gabby Glasner-Cipollini asked early on, good examples of financial services. And I know, Kevin, that's not your area, but it is mine. And I must say we've seen it in areas like compliance, trade surveillance, etc. Most of these being statistical techniques, to take an earlier point, and therefore really machine learning. And I think where you focused on that false positive rate is very much the starting point of all the issues that we ever face in it. Now, looking ahead, Andrew Ross has a really intriguing question. We've seen the Dasgupta review of biodiversity, which has just come out. And Andrew helpfully points out, for those of you listening, it's on page 478. It calls for big data and AI financial evaluation of complex biodiversity systems on a spectrum from precise and local to global supply chain scale. Inaccuracy is rife, but AI, machine learning, can surely model it, right? it does rather feel to me as if at least that section of the report was sort of just dumping onto, magically, as Trevor Hilder said earlier, this problem will be whisked away by AI and big data. But they're intending that people in financial services take it seriously and make financial decisions.
I think it's bonkers, if I be blunt. I'm the head of an AI institute, and there are just certain things, just exactly like the example I gave in the fragile families things. There are certain situations where statistical techniques, even however high-powered they are, will never achieve good outcomes, and that sounds like another area where people are just using the name and tag of AI and data analysis to try and get funding or try and get focus on their thing. Because personally, I think it's going to be very hard to achieve anything of value. You'll certainly get a number, you'll get some number, but is it of value? One's got a question there.
I've got a few more comments in a question about regulation, which is where I'm headed. Bob McDowell points out once AI systems are embedded to perform processes, it's difficult to stop them, change them without considerable disruption and sometimes litigation risk. And he wonders if you believe that standards rather than regulation is the suitable initiative to improve trust in AI. I've got a question here as well from Hugh Purser asking, what is the state of regulation concerning AI? Are politicians listening to your center?
What you call it, the state of regulation is the government has set up a number of different initiatives, and depending on which field you're talking about, the Center for Data Ethics and Innovation is a government body, funded body, to actually push forward the regulation agenda, particularly in high-risk areas like human resources or social work and things like that, where the government can see that things are going. The route that they're trying to take, as far as I can see, is assurance, developing assurance techniques rather than formal regulation at the moment for a lot of things, not everything. Some things, clearly, like autonomous cars, there's regulation coming through, but these traditionally unregulated areas like HR, they're trying to improve the assurance things, at least at the moment. I'm guessing primarily because it's an easier route to get something going rather than nothing. I suppose something is better than nothing. But my take on it is that because a lot of the emphasis is on the AI developers, I can see the AI developers developing their terms and conditions where virtually a significant part of the risk is passed over to the purchaser. And purchasers are just signing this off. And so until that balance can be corrected, I think they'll make a reasonable progress, but they won't achieve their nirvana of getting a balanced sort of inverted commas regulatory or assurance environment.
One of the things, when you came up with your developer-user distinction, I was reminded of an old model we used to use, buyer, user, shopper, chooser, where these very different roles are out there. Frequently somebody is buying something supposedly for to help the disadvantaged, so they're not the user of it. Ian Sheridan and Ed Savage have some interesting comments on that. You split the responsibility of assessment between the developer and the user. So is this assessment really just providing a document to unravel legal liability? And Ed wants to know, in social contexts, who legally owns the outcomes of demonstrably poor AI decisions, the developer or the user? And how do you think this will play out over time?
As soon as you move into regulation or assurance or doing any sort of valuation where there's a high risk that something significant will go wrong, you are moving into this overlap between your testing and evaluation and the law. There's, you can't avoid that sort of space. But who's liable? And again, unfortunately, you have to say context specific, because, like, I'll just take the example of the social work tools. The social work tool developer could do a really good assessment. But if the user uses it in the wrong context, in other words, it was developed and tested in London and then goes and uses it in the Highlands and Islands, well, that clearly is a fault of the user. Whereas the alternative is that the person in London gets sold a tool which is only half-baked, and it has they don't supply, I think, the right information for the people who are buying to understand the risks of their machine. Then clearly that's the developer. So, I know it's a non-answer in some ways, but, better analysis of context is going to have to happen, so that and I think that's what lawyers do very well at, is that's what they get paid for, is to my context is right and your context is wrong.
Well, we've really run to the end of time, sadly, and we could go on. And folks, all the questions and comments will be sent to Kevin so he can get back to you. But I'd like to end, if I could, on a pointed one. Firstly, Tangi Morgan makes the comment that the all-party parliamentary group on AI, which is led by, in fact, a friend of mine, Lord Tim Clement Jones, holds regular evidence meetings across industry sectors and topics of governance education. So well worth keeping an eye on sort of the issues that they're coming up with. But to you, some two-pointed questions. Donald McCrae would like to know, what's the best AI you've come across? And Richard Parler has a really good one. Have you come across any good examples of criminal use of AI, development of AI systems by organized crime?
Okay.
He seeks a new career.
Easy. Because my actual background comes from a healthcare environment, the ones that I've been so impressed with is the use to actually identify, improve diagnosis of X-rays. In other words, it's reduced the burden on all the radiography consultants, and the accuracy is actually has been proven in tests to actually better than actually the consultants. So it's actually reduced the cost of healthcare systems, but whilst improving it. Have I seen criminal intent? Well, one of the other arms of the Institute is actually, we're working with the UN to actually develop tools to identify how terrorists move money around the world. So they're certainly using the people with bad intentions are certainly trying to use these systems to try and evade things. So one should be careful about what we wish with these tools.
Well, Kevin, I stretched a couple of minutes because there's clear interest out there. If I may, three quick rounds of thanks. First and foremost, and always to our sponsors for allowing us to range across a whole variety of topics. And this one, I think, is dear to many of us in the technology and economic space. Thank you to the audience. You've been particularly great today. Very deep questions. I'm sorry I couldn't get around to quite all of them. And a reminder that we've got a busy period next week. And in fact, we have two events on Tuesday, one not listed, on the bond market. So one in the morning, which we're doing with Canning House, and another one at 9 o'clock, the tortoise and the hare, the continued importance of the bond market. We have Alderman Alistair King, who really knows about fixed income, high net worth individuals, the wealthy, and all of what they're really doing in that kind of lending area. As ever, go and check out the website. But very finally, if I may, Kevin, a real delight to have you on. It's clearly a topic that people adored, and we look forward to your institute moving forward, because I think we all need it. I'm unfortunately unable, even in these days of AI and big data and advanced tech, to open the floodgates of applause, but I can, in fact, provide a suitable technology, which is my Korean karmic clapper, and you'll just have to take that as applause today. Thank you so much for a really fun session.
Great pleasure. Thank you very much for inviting me. Great pleasure. Thank you.